So let's get into the function. Right-click on your AI perception component and click on Add Event. When you select Add Event, you have a couple different events that you can actually choose from. The two main events that we are going to be using is on perception updated, or you can use on target perception updated. Let me show you both. Immediately, you can see the difference between both of these. So both of these functions will fire as soon as the player enters that circle, or anybody enters that circle, as a matter of fact. And the on perception updated will basically give you an array of all the actors who have triggered that circle or who have entered that circle and have got themselves registered by the AI detection system. And that's all it does. It's going to just give you the actors. On the other hand, on target perception info updated node actually gives you a little bit more information. If you drag off of this update info, which is a structure, you can obviously break it to get more information. Now this is going to give us a target ID, and it's going to give us a target and also a stimulus. Now if you go ahead and drag off of the stimulus, which is a structure, and break it, you get even more information. You're going to get the age of that detection, and you're going to take a look at the expiration age of the detection. Now, the expiration age will only be anything higher than 0 if you set the max age to anything higher than 0. If you set this to 0, then the expiration age is going to be 0. That means your detection will never expire. The strength number, it actually gives you how strong is that detection. It's kind of like detects how close the player was or is when it was detected. And stimulus location is basically where the player was located or where that target was last located, right? And then you can actually check to see if that target actor had any type of tag, right? And then successfully sense basically gives you true if they successfully sense the player, and if it's false if they don't sense the player. That's it. It's pretty straightforward. So this is the two different type of nodes that we'll be using to kind of make the zombie stay idle, and when the player gets really close, we want them to go into a run state or a walk state and then chase the player. That's all we're going to do. And from there, the world opens up to you to do whatever you like to do with this system that you have in hand. So first, let's make something very simple. Let's use the on perception updated. We're going to drag off of this update actor, and we're going to get the first actor that it has found. Now, normally, if you have multiple enemies in the game or multiple actors in the game, you wouldn't do this. If you have multiple actors or multiple zombies and players in the game, you would actually drag off of this updated, and you would do a for each loop. And for each loop, you're going to drag the array element and do an equal, and you're going to check to see if this is the player character. If the actor is the player character, then you would connect this to the loop body, the branch to the loop body, and then connect the condition here. And then this is where you would run your function. And if this is true, that means the AI has successfully sensed the player character 0. This is a single player game, so there's only one character to detect. So again, because this is a single player game and there's only one character to select, and in our map, we only have this one zombie and one player, this is why I have chosen to do get 0. So let me go ahead and delete this. And let me show you with get 0, and then you can feel free to use the for each loop. From here, the function is going to be pretty straightforward. Previously, we were setting our target actor as a get player character, manually. So now we no longer have to do this. We can delete this player character here. We can actually get this entire function down below. We don't have to do it on even begin play. Connect this to the perception and disconnect this. And the object value will be our get 0. Now this works exactly the same thing. As soon as the player enters that circle, the game is going to update the target actor to this actor right here who has entered the sight radius of the zombie AI. Now if you press play and if you go close to the zombie, nothing's going to happen because you haven't really told it anything to do with that target actor. So we're going to go to our BT zombies, drag off of this root, and we're going to put in a selector for now, and then we're going to do a move to. And the move to is going to go to the target actor. Now, if you press save and if you press play, the zombie is just chilling. Now, if I go close, actually, we can activate our debugging so you can see it. The zombie is close, and as soon as I enter that circle, you'll see the zombie is turning towards me. And the zombie can detect that I am within that circle. Now, the zombie is not moving because we haven't really set the move speed. So in our BT zombies, we're going to go ahead and drag off of this and do a sequence. And in our sequence, we're going to set the zombie speed to walk. And once we set the speed, then we want the zombie to move to the target actor. So let's go and see how this works. So immediately you will see, hey, why is my zombie moving to walk? Let me explain to you what's happening here. So this is one of the logical things that you need to keep your eye out for when you're working with behavior trees. Now, if you notice, as soon as the game starts, the game is going to set the zombie walk speed to walk, and it's going to tell it to move to the target actor. But the player hasn't entered the zombie's circle yet. So that means this target actor is actually empty. So that means the zombie is never going to move to the target actor until the player reaches the zombie. So if I go in game and if I reach that circle, then the zombie is going to start moving, right? And you can see in your behavior tree in the background, it actually switches between that sequence. So how do we fix this? This is where we're going to be using something called a decorator. A decorator is very simple. It's just a condition. If the condition is met, it's going to do one thing. If the condition is not met, it's going to do a different thing. So here we have the selector. It's going to run a sequence between setting the zombie to walk and move to. We only want the zombie to walk and move to the player character if the target actor is defined. And the target actor will only be defined if the target actor enters the sight radius of the zombie. So until the target actor is defined, we want the zombie to just stay in an idle state. So off of our selector, we're going to go ahead and set our zombie speed to idle. What this will do is if I press play, you'll see the zombie is in a idle state. And if I go close, the zombie will start moving to the player. Now, if I were to go ahead and press play, you would notice that all the functions of this root is actually running at the same time. So it's trying to run the sequence and the idle state at the same time. And it's an actual mess that you don't really see. It's running in the background. And in our perception, we can see that as soon as I enter the circle, the zombie is going to start moving and our behavior tree is going to start acting normal. So to prevent from having all of these sequence and the idle state running, this is where we need to use the decorator. Tell the behavior tree, we want you to run this sequence only if the target actor is set to the player character or if the target actor is defined. So what I would do is I will right click on the sequence. And then as you can see, there is a node for add decorator. Now, Unreal Engine default comes with all of these decorators in game. And if you want to create a custom decorator, there's always an option up here to create a custom decorator, right? It's a condition formula or condition that you're creating, right? So right now we're going to use our target actor as our condition. So I'm going to select add decorator and I'm going to select our blackboard value as our decorator. Now select the decorator, and then where you have the blackboard option here, the key query needs to be set, and then the blackboard key needs to be set to target actor. So what this basically says to the selector is, when the selector tries to run the sequence, it's going to take a look at this decorator, and it's going to be like, is the target actor set? If it is set, then it's going to run the zombie walk speed and then move to. If it is not set, then it's going to go to idle. And the selector is going to continuously keep doing this. If I press Alt-P, you can see that only the zombie idle function is actually running. And now if I move closer to the zombie, let's actually add the perception system so you can see. As soon as I move towards the perception system, you will see how the behavior tree now switched to the other sequence to change it to walk speed and then move the character towards the zombie. And because we haven't really set up our expiration function, the zombie will continuously keep walking towards the player indefinitely. For some people, at this point of the video, this is basically good enough for them to set up their zombie game, their initial zombie game, and then they can run the game here. But if you want to see how to stop the zombie from running, if they break sight and after a couple of seconds, then continue on with the video, and that's what we're going to take a look at next here. And going back to the perception function, I quickly updated it to also show you that the for each loop works exactly the same. If I reach the player here, the zombie, as soon as I get to the sight radius, the zombie is going to start moving, and it works exactly the same. Now, this prevents you from having to cast. This is the simplest way to get your player object reference without having to cast. Both sides of the function works. I'm going to leave it as this for the rest of our tutorial here. All right, let's take a look at how to break the line of sight with the zombie. We're going to create a new function to take care of this. So we're going to create a new function, and this would be called check senses. So this is basically a monitor function where it will go ahead and run this function every minute, or every second or every other second, whichever time frame you prefer, to get updated values from our sight senses. Unreal Engine in default does not run any type of function or does not send out a notification when the player breaks sight from the AI perception system. So we need to kind of like manually take a look at it using the age function of our AI perception. So first, I'm going to select the AI perception and then set this to about 5 seconds. So 5 seconds after zombie breaking sight with the player, it's going to still keep looking for the player or move in that exact direction. And then after 5 seconds has passed, and if the zombie sight radius has not overlapped with the player, then it's going to notify the game saying, hey, I've lost sight with the player. So to build our check senses function, we need to first get the actor reference. So here where we're using this object value as the actor reference here for the player character, we're going to also drag off of this and we're going to promote this to a variable. And this variable would be our sensed actor. So that would be sensed actor. Now in our check senses, we're going to check to make sure that this sense actor is a valid variable. Only when the sensed actor is valid, we want the check function to continuously running and checking the age. If the sensed actor is no longer valid, or this is basically our player character, if the zombie has lost sight of our player, we don't want to do this check function anymore. So as long as the sense actor is valid, we need to now get the age of that sight bubble. Let's call it the sight bubble, right? It's called a stimuli, but we're going to call it the sight bubble for ease of use. Drag in your AI perception. And then here, we're going to get actor's perception. So basically, this is going to get us all the information about our sensed actor, which is going to be our player actor. And the actor node, we're going to connect this to the sense actor here. And this is an info structure. So obviously, we're going to drag off of this and we're going to break. We're going to drag off of this and we're going to do a get, and then we're going to get a reference off of this. And we're going to set it to get 0 for now. And we're going to also drag off of this get, and we're going to break this AI stimulus. Now, what this is going to do is it's going to give us that exact same information that we previously looked at. And we're going to use the age and the expiration to kind of like break the sight of the player. So we're going to drag off of this age, and we're going to check to see if the age is greater than or equal to the expiration age. The expiration age is basically this max age that we have set up here. And we're going to do a branch here and connect the condition just like this. Let's move the branch up and then connect this to the get actor's perception. And if the age is over the expiration age, then we're going to go ahead and nullify our target actor. So we're going to get our blackboard, which is going to be this variable. And we're going to set value as object, connect this to true. And the key name is going to be our target actor name, just like this. And the object, we're just going to set this empty. So this will nullify our target actor. And followed by this, we're going to take our sensed actor and we're going to do a set without connecting anything to this. So this will clear out our sensed actor as well. So essentially, we're going to take a look at every actor that the AI has recorded in its sense perception system. And we're going to get the first character that has been recorded, which is going to be our player actor. And we're going to check to see if our age is greater than the expiration age that we have set up. If it is true, then we're going to go ahead and clear our target actor from our blackboard value, indicating that the zombie has lost the player. We can also put in a little print string here and then say lost the player. And now we just need to run this check senses function every second or two. We're not going to use an event tick because event tick is going to be very expensive in your game if you were to run it on like 10 different zombies. So we're going to use a timer instead. So off of our event begin play, we're going to drag off of this and we're going to call for a timer by function name. And the function name, we're going to go ahead and copy this. And we're going to paste it into our function name just like this. Set this to looping. And the time, we're going to set this to every second. So every second, this function is going to run. And this timer is going to run on this function. And it's going to do that census check. And the last thing that we need to do is the flow control. So whenever you set up a decorator on your behavior tree, it's very important. The condition is going to check to see if the target actor is set and it's going to run. Now, the behavior tree is going to continuously run this, and there is no check to see if the target actor is not set anymore. Let me show you in game what that means. So I'm going to go ahead and play the game here. And if you see right now, the value for our target actor is set to none. So it's a failure, and you can see this red indicating that this decorator is failed. So that's why our selector has gone towards the idle function, which is good, exactly what we need. Now, if I go into the zombies circle, you can see now the target actor's value is set to the third person character. However, if I now exit the circle and wait for that timer to run out on the age, you can see immediately the target actor is set to none, but the sequence is still running. That's because we have set up the decorator, and under flow control, when the result changes, we have set not to abort anything in our sequence. So we need to be very careful with our flow control when we're setting up Blackboard keys, because we need to define what needs to happen if the value or the condition changes. Behavior tree is not going to automatically stop it. You need to notify. So under observer aborts, we're going to go ahead and observer abort the self. So that means it's going to abort this entire sequence. So let's go ahead and try this now. So if I press Alt P, it's going to play the game. Let's activate our perception debugging. So I go, zombie is chasing me, the bubble is great. Now I exit and I wait until that bubble disappears, which is our expiration, about 5 seconds. And as soon as it expires, now you can see our behavior tree has switched to the idle function. Because the target actor is no longer set, that means our flow control has triggered to abort that entire sequence. If I go back into the bubble, everything works to be fine. The zombie can see us again. And now if I exit the bubble and wait about 5 seconds until that age runs out, ta-dam, zombie can no longer see me. All right, folks. So this is all I wanted to show you in our AI perception system today. I know it's a little long video, but there's a lot of information here to cover, so that's why it's a little bit long. But from here, you just expand your system to do whatever you want to do in your game, or whatever you want your zombies to do in your game. You can create as many tasks as you want, and you can make it as intuitive as you need to make the zombie fit your game theme. In the upcoming videos, we're going to take a look at how to create different types of zombies and different conditions for them. But ultimately, everything comes down to this AI perception system, and this is what we're going to build off of. Once again, thank you very much for stopping by. You can show your appreciation by hitting that like button, and if you haven't already subscribed, it's free to do so. So hit the subscribe button as I create more of these videos for Unreal Engine in the upcoming days, and I'll be posting more of these. I will catch all of you in my next video. Bye-bye for now.